global average, we recycle only 8% of plastic waste. The rest is incinerated and landfilled. We're now producing over 350 million tons a year and have accumulated over 8 billion tons in our landfills and natural environment. My name is Tal, co-founder and CEO of Plastic-Back. We've developed a solution able to convert plastic waste back to its original valuable form. The raw material developed by Plastic-Back can then be used to create new plastics and alternative fuels, contributing to a more circular economy. We aim to be the missing link between the waste handlers and the petrochemical industry, which is heavily dependent on crude oil drilling. Using our technology, plastic waste will be converted to crude oil, which will then be used to and upcycled by the petrochemical industry at crude oil price. The plastic-to-fuel market will reach 2.6 billion by 2026. We aim to work with treatment sites. These facilities receive thousands of tons of plastic waste and landfill most of it without benefiting from the waste potential. In the EU alone, there are over 500 sites, treating over 60 million tons annually. These facilities are affected by reducing landfill space and growing regulation and are a natural beachhead market for our technology. Utilizing our technology, treatment of plastic waste can be done in room temperature, a huge economic and environmental advantage compared to competition. We can treat difficult waste streams including PVC, mixed and contaminated. And last but not least, since the conversion is done in room temperature, greenhouse gas emissions are reduced. In order to close the loop, we use chemical oxidation. Our unique process creates free radicals that are present in nature and even in our bodies, but have never been used for plastic treatment before. These free radicals are able to attack the carbon-carbon bonds of the plastic polymer and break them down into smaller and smaller fractions. The plastic waste is inserted into the main reactor. With water and oxygen, the reaction occurs. Then, with a series of pumps and silos, we're able to separate the end product. We've been selected to plug and play in the Alliance to End Plastic Waste Acceleration Program. As part of this program, we were able to ask the leading companies in the petrochemical, plastic manufacturing, and waste handling sectors questions to verify our assumptions. We asked the waste handlers what limits them in achieving higher recycling rates. 80% said technology. We asked the petrochemical industry if they're willing to pay a premium for plastic-derived oil compared to conventional crude oil. 75% said yes, they are. In 5 years' time, and considering our beachhead market only, we will achieve 1.3 million profit margin annually by addressing only 3% of the total addressable market, material recycling facilities. A facility which can be operated for 10 years will produce profits of $3 million for Plastic-Back and around 6 times over for the customer. We have identified market share and products per customer per year as the key drivers. Our solution reduces CO2 emissions compared to landfilling waste and compared to crude oil drilling. For every ton of plastic waste not landfilled, we save 250 kilograms of CO2. For every ton of plastic-derived oil, we save 500 kgs of CO2. In 5 years' time, we will save almost 500,000 tons of CO2 emissions. We're a team of chemists and entrepreneurs dedicated to fixing this problem. We're also collaborating with the Hebrew University with IP and national phases in the EU, US, and China. We've won second place in Shell's prestigious New Energy Challenge and first place in Israel's biggest circular economy competition. We hope you'll also join us on our journey in turning the tide on plastic waste. Thank you.
Thank you very much, Plastic-Back, reducing carbon emissions. Jury members, are you impressed? What are your questions? Please raise your hands. Yes, I can't actually see. I think that's, yes, go ahead, go ahead.
Andrea, you're on mute.
Yes, you're mute. Yeah. Yes, please.
Sorry.
Go ahead. Yes, Michelle. Yes.
Thank you. Apologies. Just to share questions regarding the technology. At what level are you right now? What is your scale where you are working right now? And the second one, is this a high pressure process?
Yeah, so I'll start with the second question. First of all, this is a low temperature process that happens also in room atmospheric pressure. So compared to conventional pyrolysis and gasification technologies, which use between 600 and 1,200 degrees, we use room temperature, which is a great benefit. And as far as scale, right now we're in a lab scale. We're finishing up a few POCs. And in early 2021, we're going to move to our first pilot plant, which is planned to be a 60 kg plant.
Okay, thank you.
Thank you. Anybody else in the jury? Yes, Edward.
Yeah, I do have a question in regards to the to the collection of the waste and how will that be done, and what are the challenges you face there?
Yeah, so collecting and pre-separating the waste is one of the biggest bottlenecks of the plastic waste industry. And one of our advantages is that we can take in mixed plastic waste and then separate the end products later. In terms of where we would get this plastic waste streams, we work in joint ventures with the material recovery facilities. These facilities receive thousands of tons of plastic waste and landfill most of it without benefiting from the waste potential. So we would work in joint ventures with these facilities in order to get the plastic waste.
Thank you. I think I saw Michelle raise her hand.
Thank you. Yes, very interesting. Quick question. Can you tell us a little what you see is the social impact of your innovation?
Yeah, so the plastic to fuel or the plastic to raw material market is supposed to generate 40,000 green jobs in the US alone. And although we're trying to automate the technology as much as we can, we will still be creating green jobs in the terms of logistics and sales in the green energy sector.
Nice and concise answers. Shloka, maybe a short question still?
I just wanted to know a little bit more about the competitors in terms of other products in the market. If you could explain a little bit.
So the plastic to fuel market is dominated by high temperature technologies, pyrolysis and gasification. These are the dominant competition we have. And compared to them, we're operating in very low temperatures. We're able to treat different plastic types, including PVC mixed and contaminated, and we're able to reduce greenhouse gas emissions.
Thank you very much. For now, Plastic Bag, best of luck with your pitch, and the jury members are taking notes. Farid.
Absolutely, they are, and they have to, because they have to make a decision on who's going to win the awards. We're back on track. 7 more pitches to go, 16 in total, and we'll have a winner later this afternoon. And the great thing is we have already visiting so many parts of the planet. We've been to Australia, we've been to India, we went to Denmark, and also here in the second round with 8 more pitches in total, we're also spanning all over the globe. We go to Egypt, to Uruguay, to Mozambique. I mean, there's not one continent which is not being part of this climate launchpad. Let's go to the second pitch here in this round. We go to Bangladesh, to